that more difficult than what I've learned. So yesterday, some student tell me, Eugene, omega should be varying with time. Okay. To be frank, I also panicked yesterday because the entire equation is going to be out the toilet bowl. It's omega, it's not constant. But fortunately, when I reread the question, we have a constant what? Angular velocity. So to those of you that point me out, there's some problem with the with my answer. I really appreciate that a lot. Okay, this shows me one thing. Fundamentally, you guys are strong. That's why you guys do well for both 2P and what? 2Q. Okay, wait till you see 3A. Anyway, so from here, I'm going to carry on with our problem. Okay, so this is just math. I know I don't need to do it. I could just like skim it through, but that's not the way we work. So I'm going to take out d plus r cos theta because we have d plus r cos theta on both equation. One over here and dr cos theta and one over there. Okay, so we can factor it out. So we factor it out. We have d plus by r cos theta, and then we multiply by L r omega minus d sine theta omega close and then close bracket, then minus by L r omega d cos theta plus r. We still have the 2, and we have minus r sine theta omega. I'm going to close this bracket. I'm going to do this twice, and then the denominator, and this will be equal to d plus by r cos theta to power 4. We get rid of this, we get rid of this, we have 3. So now we are left with, next thing, I'm going to take out the thing that I'm going to move out is going to be the r omega, okay, LR omega on both sides, and I have a omega over here that can factor out. So this is just doing what? House cleaning. LR omega squared. Then I will have d plus by r cos theta, and then minus d sine theta. And then finally, on the other side is minus d cos theta plus by r multiplied by 2. And then I have bracket minus r sine theta. Okay. I always am very proudly to say that you guys are better in this than me, which you are. And then over here, denominator is d plus by r cos theta, 3. Okay. Then from here, we have what? We have, I think I've done something wrong. I can also take out sine omega, sorry, sine theta. Sorry, I was blind. Not watching things properly, Eugene. I can also factor out, hey, come on. I do apologize wasting your time. Okay, sine theta, we can also take out sine theta with L r omega squared. I can take out sine theta. Then over here, we will have dr plus by r cos theta minus d minus by d cos theta plus r multiplied by 2 multiply minus r, close bracket again, and then the whole thing go below. So d plus by r cos theta about 3. Okay. So from here, we're almost done. L r omega squared sine theta, you have minus d squared plus by or minus dr cos theta brain fart plus by 2 dr cos theta, and then minus plus by 2r. Okay, plus by 2r. I think I have a squared missing, 2r squared. Okay. Then over here, 2dr 2r squared. Yep. And then this is d plus by r cos theta to power 3. Finally, we are done. Okay. Are we done? Yeah. So L r omega squared sine theta bracket. You have 2r squared. Okay, so this is done. Minus d squared. This is done. Minus 1 plus 2 plus by dr cos theta over d plus by r cos theta, and this is power 3. Okay, that's it. Okay, so you can see for a problem like this, analysis is only 10%. Mathematics capability is 90%. Okay, so math, you have to be what? Very comfortable. Are we clear? Okay. When I say analysis, what it means is to come up with a diagram like this. This is what we call analysis. The analysis part is not difficult at all. Okay, the analysis is straightforward. Okay. Question so far from anyone? Are you okay? So my next question for you is, what does PhD stand for? Anyone? Hey? What does PhD stand for? How many of you want to get a PhD? Any volunteers? None? One? Okay. PhD stand for permanent head damage. Okay? So be careful what you wish for. You don't want too many people having brain damage. Okay. So where are we now in the course? We're going to start on a new topic. Okay. So the new topic that we're going to start, so your term test will be until here or they're included. So where we are now, if you were to look at the entire textbook, this is Hibbler. Chapter 12, 13, 14, 15, and chapter 15 up to chapter 15. In our context is we put it in the toilet bowl. Are we clear? So we know nothing about golf balls and tennis balls. We know about rigid body. Okay. We have just completed chapter 16. Now, I did not teach relative motion using rotating axis. Okay. It's not common that we use it, but we do. Okay. So now we are going to go into replace kinetics of rigid body for forces and analysis. Now, this topic is very similar to P04. Okay. However, the only difference is dimension of forces will not be equal to what? 0. Okay? Will not be equal to 0. So, as Dr. Koshi taught your thrust analysis, bending moment diagram, shear force diagram, What do we mean by positive shear and positive bending moment? What does it mean by positive shear and positive bending moment? Oh, you know what? Yeah, okay. So let's begin. Come on, you guys are killing me, man. So before we go on regarding forces, so we are going to. Hello. Okay, no one. So we are going to deal with chapter 17 from now on. Okay. So chapter 17 will be really quick because the thing that we learned in chapter 16, okay, is the tough part. 17 is just summation of forces, but it's not equal to what? 0. That's the only thing. Okay. Then we have to go to chapter 18 and chapter 19. Okay, so we have 3 more chapters to go. Vibration, you finish already. Good news. Okay, right, here we go. So now, before I go on, okay, what do we mean by positive shear and positive bending moment assumption? What do we mean by that? Okay, so if we have a body that is simply supported, right? And this is our load, for example, P. And this case, this is L/2. And pardon my drawing, this is also L/2. Point A, point B, point C. Where will the structure fail? Yes. Why? Eh? No. Failure will occur at point B because bending moment is going to be at its what? Maximum, right? If some of you cannot remember, I will do an experiment for you. Okay. Now it's important I teach this in dynamics also. Later on we do analysis, we have to know. Right. So why would the structure fail at B? If I want to break this ruler, what must I do? If I use tension, you guys automatically can. If I use tension only, do I need a lot of force? Yes or no? If I start to bend, do I need more force? Yes. Where will it fail? It will fail at the way. Center. Don't memorize this shit. You get what I mean? Physically, do it. Break your ruler. Are we clear? This is mechanical engineering. This is not electrical. Electrical is what? And you see electricity. And you see magnetic wave. He is so much getting fired today. You can't see them just now. That's why you are here. Mechanical engineers always get speeding tickets. Why? Because when there's rules, we never what? Follow. Electrical engineering, please go to IR. Oh. In short rod. Constant current, right? Constant voltage, constant current theory, yes or no? They obey the rules. We keep on breaking them. Okay, so that's why we are mechanical engineers. Now, always remember your datum is on your where? This is where your Can anyone answer me why geometric datum is always on the left-hand side? Not on the right-hand side. Yes. Yeah, because whenever you draw your shear force and bending moment diagram, you start from where? Your geometric datum 0 always start from the left-hand side, and you have a shear force, and you have your what? Bending moment. Okay. More importantly is what?